And we're back with the next example of looking at forces and friction in objects. So here we have a pumpkin is pulled with a rope at 20 degrees, which sounds familiar to the question we had a moment ago, okay? Only now we've switched it to a flat surface, okay? And we keep the same coefficient, the same pulling force, so we're gonna see what happens when we that one little change happens when going from a angled surface to a horizontal surface. So again, we're going to draw all of our forces and then solve for acceleration of the pumpkin. Okay, so let's go ahead and turn the page and look at how we're going to solve this. Okay, so I have drawn out my component forces. Or excuse me, I've drawn out my force diagram. Okay, my force of gravity, my force normal, my force of friction, my force of tension. Okay, this force of tension is going to have to be broken up into different pieces, and then we can start looking at my force in the y, and then I can finally get down to my forces in the x. So let's go ahead and do some of that. Okay, so I did a little work here. We now have the force in the y, the force in the x, and the force of gravity. So I can start plugging in some of these numbers. So we know the force of gravity is 196. We know the force in the y is 17.1 newtons. Okay, now we need to start thinking about signs. This is going up, gravity is going down. Okay, and then our force normal is the last piece. Okay, so we're going to have to do our 196 minus our 17.1. Okay, so that means our force normal had to be 178.9 newtons in order for all that to equal 0. Okay, so now we know the force normal. Notice this is not equal and opposite to gravity because we have this other upward force here. Okay, so they all sum up to 0, so that gives us our force normal, which means we can now find our force of friction. And we had 0.1. So our force of friction equals 17.89 newtons. Okay, so that should fall fairly close to what we had last time. We had 18.4 on the other one. Okay, so now we have the force of friction. So now we can do our final step down here. Okay, we can look at the sum of the forces in the x. So we had F of x plus force of friction, okay? And that's going to equal mass times acceleration, okay? Those are the only two pieces we had in the x, okay? So we had 47 newtons pulling to the right, and we have 17.89 newtons pulling to the left. Okay, and that's going to equal our 20 kilograms times A. Okay, so I just plug this into the calculator and I get my acceleration. One thing I want to point out before we leave here is our coordinate system. Okay, so in this coordinate system, most of my variables fell along here and I kept it within the plane of the surface. Okay, so this was my x and this was my y. When we looked at this one, the surface was this way, so I called this x and I called this y. Okay, that's important because when I did this one, I had to take gravity and break gravity into components going with or parallel to the surface and perpendicular to the surface. Okay. With this one, gravity was already perpendicular to the surface, so I had to take the string and break it up into parallel and perpendicular pieces. Okay. And with no gravity as a force here, then this is definitely moving. And it was far more than friction was, so we did have acceleration. Okay. So if this number is less than friction, it becomes 0. If it's more than friction, then we get motion. Okay, so that's the piece we want to take away from this one.